Welcome back to Algebra 2. Okay, so we have a reminder of how to find amplitude and period. Amplitude is going to be A, but it is always the positive part. So in my first problem, I have an amplitude of A. And I can find B. B is not the period. In this particular case, B is always here, right in front of the X. If B is 1, the period is 2 pi. For our second problem, the amplitude is the positive portion of 2/3. Because B is 2 pi, and the period is 2 pi divided by B. Well, 2 pi divided by 2 pi is 1, so our period is 1. Sometimes we need to be careful. K is put in the wrong place here. This is K, technically I should say plus 4 over here. And A is actually 1, but it is flipped over the x-axis. B is 3, and the period is always 2 pi divided by B. Don't need to simplify that at all. And on my last one that I'm going to do here, A is going to be the ugly number. B is 2. And 2 pi divided by 2 is going to give me a period of pi. Just a small review of amplitude and period. So we need to be able to do 3 things in this section, and you will actually have 2 days to work on this assignment. We need to interpret and use frequency. We often deal with frequency in terms of sound waves. We're going to write trig functions, and we're going to use technology to find sinusoidal regressions. Sinusoidal is a fancy word for sine. So physics is used in dealing with waves, particularly with sound waves. It's the number of cycles, which is a period, in 1 second. It's measured in hertz. So 1 hertz is 1 cycle per second, or 1 period per second. Higher pitch sounds are actually faster, and lower pitch sounds are going to be slower. But a dog bark, that would be about 500 hertz. So frequency and period are inverses of each other. So the equation that we're going to use is going to be over here. The frequency in hertz equals, instead of 2 pi over B, flip it, B over 2 pi. And we can solve this equation for B, solve this equation for the period, solve this equation for frequency. Don't forget, cross multiply and divide. So if we want to write an equation when we have a tone that has a frequency of 100 hertz, we're going to say 100 equals B over 2 pi. In order to solve that, we're going to multiply both sides by 2 pi. And so B ends up being 2,000 pi. So remember, B goes in the equation, right? So we have y equals, A is just going to be 1. We don't have anything else to show that. And our sign is going to be 2,000 pi. So remember, we usually use the period as 2 pi divided by B. So 2 pi divided by pi cancels, 2 cancels. I need a 1 left on the inside. So 1 over the frequency is the period. So that 4th mark is going to be 1 over 1,000. Then we could do 1 over 2,000 and 1 over 4,000. So we don't have anything that shows how the volume is, so we're just going to have a volume here of 1 and -1. we wrote it as a sine function. So in a sine function, I'm going to start at 0, go up the amplitude back to 0, down the amplitude back to 0 again. So it doesn't look like it on our graph, but there are 1,000 of these in 1 second. Let's take a look at another one. I've got the equation. I want to find out what the frequency is. Remember, the frequency is b over 2 pi. And in this case, b is 0.75 divided by 2 pi. I am not allowed to leave decimals inside of a fraction. So what could I do with this? I could say that 0.75 is 3/4. I could decide, okay, I'm just going to multiply both of these by 100, top and bottom. There's a couple ways to get the decimal out of the fraction. And this is going to be 200 pi. Then I might notice that both of those are divisible by 25. So that would be 3/8 pi. The only part of the equation that I'm going to care about is going to be b. Frequency equals, instead of 2 pi over b, b over 2 pi. I also need to be able to write equations of lines that I see. A couple things that I want to try to figure out is, where's the halfway line? So halfway between these 2 points, which are a high and a low, is actually going to be at +2. So that is going to tell me my k. I have to make it a sine function, not a cosine. Well, fortunately, it does start on that line. It goes up 3, it goes down 3. So that's going to tell me that my a is going to be 3. Then I need to figure out my period, and I need to look at one cycle and only one cycle. That cycle is going to end right there, and that mark right there, the only mark I see is pi, so that one is going to have to be pi over 2. So my period is pi over 2. So 2 pi divided by b is pi over 2. Cross multiply, I'm going to get 4 pi e pi, dividing both sides by pi. So my equation is going to be 3 times the sine, e angle, and I just have k at the end, so +2. That's our first equation. Let's take a look at another. So I have to write this as a sine function. I need to find that line in the middle. I'm going down 1, I'm going up 3, so my line in the middle is going to be right about here. That means that my vertical shift, sometimes we use d for k, I'll show that on a later slide. K is 1, so I am going to actually have to phase shift this. And I have 3 points on this graph, actually 4 points that I could start at. If I start right here on the graph, then my graph is going to go up positive first. That's probably a good thing. So here's my phase shift right here. And I need to look at my units. I see pi is here, pi over 2, and look like I'm halfway between. So h is going to be 3/4 pi. Then I need my amplitude. And the last thing I need is my period. So I just need to try to find one total cycle. And my best place to probably find that, even though I'm doing a sine function, if I start at 0, I'm going up, back down. I actually end right here, one cycle. Pi, 2 pi. This guy that is not labeled is actually 3 pi. That is the period. So since the period is 2 pi divided by b, cross multiply, the b's got to come up. And that means I need to divide both sides by 3 pi. Pi cancels, and b is 2/3. Have everything that I need to plug in. I actually have all 4 parts here. So remember that I've written the equation A sine B on the outside, parentheses x minus the phase shift plus the vertical. That's where everything goes. A is 2, B is 2/3, x minus, my shift is actually positive, but it shows up as a negative here, and plus 1. And that is our final equation for that problem. Let's do one more. In this case, I'm always looking for that midline because that's going to tell me my k. I'm counting in 1, 2, 3, 4, 5. So k is 5. Do I start a sine wave function right here? Yes, I actually do. One cycle goes to here. And that point right there is going to be my period. Well, I'm not counting in pi. I'm counting in 2, 4, 6. This is going to be an 8. So my period is 8. And that equals 2 pi divided by b. So when I cross multiply, I get 8b. And dividing by 8, b ends up being something with pi in it this time, which is perfectly okay, pi over 4. So it turns out that I have a couple things going on. The last thing I need to find is my amplitude. I'm going up 2, down 2 from the center line. So A is 2. That gives me an equation. A sine, B goes on the outside. But since I don't actually have a phase shift, I'm just going to say theta here. Don't need the parentheses at all. And plus 5. Okay, there's a couple examples of writing an equation for a graph. You are going to have a couple of those. We've done regressions for linear functions and quadratic functions. We have used a calculator. So we have used Wabbit-Emu as one of our calculators. There's several other options. Wabbit-Emu took me a couple times to get it coming up on my phone correctly. Taculator is one that Jordan found that looks like it will work on the iPhone, very similar to this. And if you can't find any of those, please use desmos.com, and I will have a separate video for how to do those. So because sine and cosine are just shifted, we're only going to use sine regressions. The calculator will actually only give us that choice. There's a slight difference in the form of the equation. In the equation, I don't have a second set of brackets. I just have the 1. B is inside it. This makes C not the phase shift. C divided by B is the phase shift. My preference is the other equation, but this is the way we tend to get it. Notice instead of H and instead of K, we tend to use C and D in the calculator. So let's get started. I'll go through 2 examples on this. Our first one is we have months, and on the 15th day of each month, which is going to be in the middle, we're going to have January, February, March, April, May, and we have number of hours of daylight. So we need to turn our calculator on and go to Stat. In Stat, we're in Edit, and we hit Enter. I've got some data in here, so I'm going to go up and clear. Do not delete. Go over, up. Notice I'm on L1. Clear, delete. Now that I have this, I can put my data in. So I have my months entered, then when I arrow over, I start at the very top. Okay, one of my checks that I want to make sure that I do is look at my columns down here and see that they are the same size. I tend to scroll up through things, double check numbers, make sure I didn't forget a decimal point, any of those things. And then I need to do a couple of things. I'm going to start out on y equals, which is up here. And I've got some junk in here, so I'm going to clean that out. And notice that plot 1 is dark. I want it dark. That means plot 1 is on. If it is not on, I go onto it, hit enter, and it will be on. Then I need to hit the zoom key, and in zoom we have statistical data, and that means we need to do zoom stat. When we hit zoom stat, we should see our data, and hey, that kind of looks like a wave. So now we need to come up with the equation that goes with this. Stat, calc, and I need to scroll down in my list. If you have a slightly different calculator, the letters will be different. My sign regression is letter C, and I'm going to hit enter. As long as I put data in L1 and L2, I don't have to mess with a lot of other things. The one thing that I want to do is put the equation in the graph, which means I need to go to vars, yvars, enter on function, enter on y1. So my equation just says sin reg y1 and calculate. See this line right here? Don't hit a single button on the calculator until you have written the equation. So the top line is going to tell you what format the equation goes in, and then all of these here are going to be in the easiest format for us to simplify the problem. So I have y equals A, first one for A, let's go to 2.76, round to the nearest hundredths, times sine. I'm going to start with parentheses because the first line is telling me to. B is 0.51 x. Now it says plus up here, and I notice I have a minus, so I'm just going to go ahead and write minus 1.59, close the parentheses, plus 12.13. So there's our equation. We want to write it before we hit any buttons at all. Once we have that, then we can hit the graph key, and this will give us a good idea of, does the equation fit our data well? And we notice that it looks like it's going almost exactly through every single point. This is a very good fit for the data. Now, once we have that, I might want to solve the problem for some specific point. Actually, we won't need to do that. Now, it is possible that I might want to find out what the equation is going to tell me for some specific time, and I can actually hit trace. Notice on trace, the very top here says I'm currently in the plot, and if I arrow up or down, now it says y1, and it looks hideous, but it follows our equation. And I'm on the line, I'm on the curve, and you can see it follow the curve. And since 1 is January 15th, 2 is February 15th, 3 is March 15th, if I want to find out what it might be on March 1st, well, if this is 2 and this is 3, I want to know what it would be at 2.5. So I can actually type in 2.5 and hit enter, and it will pull me back. You see that it's shining right here in between February and March, and it says at that time I would expect the hours of sunlight to be 11.28. Solve problems with this equation once I find the actual equation. I could have also plugged in 2.5 here and done my own number crunching right here. Okay, let's take a look at another problem. In this particular problem, it looks like I have months and time, but I am going to pull the calculator back up. So I have all data in here. I need to clear that data out. So I need to clear it in y equals. Plot is still on. I need to go to Stat, Edit, hit Enter, and I've got to get rid of some data. Now, I don't actually have to get rid of my L data because it's still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm just going to keep that data there. There's nothing wrong with clearing it out and starting over. And now I like having cleared data. I'm ready to plug in my y's. Okay, it's new data. If I just hit graph, you may or may not see it. I need to go zoom, scroll down and find zoom stat. On zoom stat, I hit enter, and no, it looks a lot like the last graph did. So I hit stat, calc, need to scroll down to sine regression. That's my old data up there. I still need to put this in the new format, so I need to do vars, yvars, function enter, y1 enter. And I am not going to leave this screen. I am going to look very closely at this format here, and I'm going to follow that format, rounding all of these numbers. So A is 21.8. I can write the times key in there, doesn't matter, sign. Starting parentheses, B is 0.51, x minus 2.18, close, plus 51.3. And there we have, I guess I should have put y equals, our full equation. And if we were asked to find something at February 1st, March 16th, whichever, we could use the equation, plug in our information, and find that. Okay, you will have a couple problems that you will need to do. The regressions. On those regressions, what I'm going to expect to see is your equation. And then if they ask you, hey, what would it be in the 12th year? Then you'll be able to answer those questions. Again, Desmos is going to have a separate function, and I will give you